Hey, we're going to do a little science experiment with conductors and insulators for electricity. I've got a simple circuit right here, and this is a conductivity tester. That simple circuit, right now, we call it an open circuit. But if I bring these two ends together, it closes. And as it's that closed circuit, the bulb lights up. I want this open circuit because conductors conduct electricity. That means the electrons can flow through that item to close the circuit. And so a conductor, when I put it between these two alligator clips, will light the bulb. And it will close the circuit. The electrons flow through that and completes the path for electrons to flow. The other items, the opposite of an electrical conductor, is an insulator. An insulator does not allow the electrons to flow through. So if I put an insulator between these two alligator clips, the bulb won't light. So it's a pretty simple way to test some items. The piece that's really critical is to make sure when you're testing them, you don't accidentally touch the metal ends of the alligator clips together, because you'll get a false positive. And then you'll think an insulator is a conductor. And here's another cool thing. These little rubber grips on the alligator clips, I have to touch the metal parts of the alligator clips. If I touch a metal to the rubber, no light. So that's what happens. This is a conductivity tester. So you have to draw what that looks like before we test the item. That's your question 1 on the assignment that's linked with this video on Seesaw. Your question 2, what happens when Mr. Glover touches the ends of the conductivity tester together? There's your answer. Question 3 on that assignment, how will you know if the object is a conductor or an insulator? Well, if it's a conductor, lights up. If it's an insulator, no light. So let's test some materials. Our first material that we're going to look at is this iron nail. Iron is a specific type of metal. We talked about this last year. Iron is one of the metals that's attracted to a magnet. Let's test it. Iron nail is a conductor. Another item is a glass marble. Glass marble, conductor or insulator? Touch the ends. Insulator. A rubber band. Insulator. Aluminum nail. Nail made of a lighter weight metal. Aluminum is non-magnetic. This is not attracted to a magnet. We tried it with aluminum foil last year. And I also have a piece of aluminum foil here. Let's test it. Conductor. So if aluminum nail's a conductor, let's check the aluminum foil. Conductor as well. Popsicle stick, made of wood, or a wooden craft stick, however you want to call it. Conductor or insulator? Insulator. Piece of yarn, string. Conductor or insulator? Insulator. Penny. Conductor or insulator? Conductor. Final item, plastic spoon. Insulator. Double check. I'll even go to the back side. I'll even move the clips closer. It's still an insulator. Plastic. Now, take a look. These were our conductors. What material are good conductors of electricity? What material do these 4 items all have in common? Follow-up question. It's also on your Seesaw assignment. What are 3 materials that are excellent insulators. And here's a clue. One of those, actually two of those materials help to keep the electrons in on the wires of these circuits. So, insulators, conductors, moving electrons through. Good luck on your assignment, and I hope you enjoyed this experiment.